What exactly is electricity? Electric current is the name for the flow of small, negatively charged elementary particles electrons in a specific direction. This usually happens within a conductor of conductive material. Lightning, however, shows us that power can also flow without a conductor. Power flow is most easily explained using the example of a battery. Electrochemical processes in the battery separate the negatively charged electrons congregate at the negative pole, while on the other side, the positive pole, only positively charged electrons are found. This creates an electron flow from the negative to the positive pole. The principle on which electric current is based is the property of the electrons to always strive for a neutral state. The current I indicates how many free particles move through a conductor, such as the cable, at the same time, and is measured in ampere. Electricity needs voltage. The electric voltage is the driving force allowing free electrons to move and therefore the precondition for the flow of electricity. It is measured in volt V. This force is the result of the difference in charges between the positive and negative pole. The special state in which electrical voltage creates mechanical forces on the charge carrier is called the electric field. What does electricity look like? Electricity is invisible, despite the fact that it is often portrayed in the form of a yellow lightning bolt. Like the wind, which makes trees sway and drives wind turbines, electricity cannot be seen but is only identifiable through its results. Normally, we can't see electricity. It's like gravity, an invisible force we only recognize when it acts upon other objects. In the instance of electricity, the most common way it affects objects is by charging electrons, and because these are so small, so plentiful, and move so quickly once charged, they are all but invisible to the naked human eye. Direct current and alternating current, a tense relationship. The electric current generated, for example, by batteries is known as direct current, as its direction does not alter over time. Most electronic home appliances, such as the radio, computer, or LED lights, require direct current as their power supply. Because the electricity that comes out of the wall socket is alternating current, these appliances have built-in switched-mode power supplies or transformers that convert the electricity. A special form of alternating current flows through power grids: three-phase alternating current or just three-phase current. It consists of three individual alternating currents of the same frequency, which have a fixed phase shift of 120 degrees to one another. How fast is electricity? Electrons in a live conductor are slow. Their so-called drift speed depends on the material. For copper wire, for example, their speed is less than 0.5 meter per hour. The key to swift transmission of electricity is not the speed of electron movement, but the transmission of the trigger pulse. This pulse is transmitted almost instantaneously from electron to electron at a speed of about 2/3 that of light speed, and is, therefore, faster than a bolt of lightning. Frequency. The frequency F is a physical factor of alternating current and is measured in hertz. It indicates how many fluctuations the electricity makes per second. The European electricity grid is an alternating current grid with a frequency of 50 Hz. In North America this is 60 Hz. This means that the electricity changes direction 100 times per second and therefore completes 50 oscillation cycles per second. How does 50 Hz sound like? Pitch is also measured in hertz. Take for instance the strings of a violin. If one draws the bow across the strings, they begin to vibrate and the sound can be heard. If you have good ears, you can hear a very low tone underneath a 50 Hz power line. Contra G, resistance and conductivity. The electrical resistance R is a fundamental factor when designing power lines. The electrical resistance indicates how strongly the electricity is slowed down as it passes through a certain material. In other words, it describes how much voltage is needed to transport the energy through this material. The electrical resistance depends on the length and cross-section of the line. The shorter the line and the larger the cross-section, the lesser the obstruction of the electrons. What time is it in grid time? The grid time is often used as the basis for the time display on electrical appliances. In Europe, the grid time is based on the standard grid frequency of 50 Hz. A second corresponds to exactly 50 oscillations of the alternating current. Deviations in the grid time are caused by frequency fluctuations. If the frequency is less than 50 Hz, the 50 oscillations require a bit more time. At more than 50 Hz, they happen faster. The grid seconds therefore last a shorter or longer period, depending on the frequency. If the deviation between the grid time and the universal time of the atomic clocks amounts to more than 20 seconds, the frequency in the grid is adjusted accordingly.